Concept 3, Classifying Systems of Linear Equations. So this needs to get into your notes, this table. It's also in your book. What this does is this has the number of solutions for each of our three types of lines, and it has the description, which I think is really helpful because it lets us know that if they're intersecting lines, if there's just one number of solution, they're going to have different slopes. If they have an infinite number of lines, if they're the same line or coincident lines, they're going to have the same slope and the same y-intercept. If there's no solutions, it's an inconsistent system and there's parallel lines, they're going to have the same slope and different y-intercepts. All right, you need to know the vocabulary for the fact that a consistent and independent system is a set of intersecting lines. A consistent and dependent is a set of the same lines or coincident lines. Okay, this vocabulary doesn't come up very much, so you don't need to use it. You can call them the same lines. I don't have a problem with that. And then the last one, that's inconsistent system, where you have parallel lines. Okay, if you haven't gotten all this, go ahead and pause the video, make sure you get that down, and then we'll go on to the next step. All right, so now instead of looking for solutions, all we're looking to do is classify the system. Okay, when I have a graph, it's usually pretty easy to recognize the three different types of systems. All right, this one, even though they don't intersect on my graph, I can tell that these slopes are not the same, right? They're not perfectly parallel. This green line has a slope of 1, right? It goes up 1 and over 1 every time. This red line has pretty close to that, but you can see it doesn't exactly go up 1 and over 1. It gets off, and so it actually rises more than it runs. So eventually these two lines will meet. So they are intersecting lines and a consistent and independent system. Okay. Now this equation, we can look at it. You might recognize right off what kind of system it is if you can do that in your head, but my suggestion is that you do not try and do that unless it's pretty obvious, because it's very easy to get the positive and negative signs mixed up in your head if you're trying to solve it in your head. And the difference between a positive and negative is going to be a parallel line and an intersecting line, right? Either parallel or crossing in just one place. So my suggestion when you do these is, especially if you've got one already in slope-intercept form, just get the other one in slope-intercept form. All right, make sure that you have it done correctly. It shouldn't take you too long. In this case, I'm going to move 6x over, so I'm going to subtract 6x. So I'm going to have negative 2y is equal to a negative 6x plus 10. Divide by negative 2, divide by negative 2, divide by negative 2. And yeah, I'm going to end up with y equals negative 6 over negative 2, or 3x, positive divided by a negative, minus 5. And they are the same line. They are coincident lines. It's a consistent and dependent classification, or consistent and dependent system. All right. And now this last one, if I'm looking to just classify and I don't have them in a slope-intercept form, I don't have either one in slope-intercept form, what I might do is figure out if it's possible for them to have the same slope, right? Because if they're going to be either consistent and dependent or inconsistent, they've got to have the same slope. So if they don't have the same slope, I automatically know it's going to be a consistent and independent. I'm going to have intersecting lines. So when I'm doing that, I'm going to basically take my coefficient of x and my coefficient of y, and I'm going to divide them, right? If I moved my x value over, so it was on the other side, it would be a -2, and then I would divide by -3, right? So I would have a -2 over -3, or a 2/3 slope. For this one, if I move my x over, it would be -10, divide by 4, divide by 4, and I would have a -10 over 4, or a -5/2. There's no way that slope can be the same. So this has to be, two intersecting lines, has to be a consistent and independent system.